Good morning again, fourth graders. It is now time for today's lesson. So we are going to be talking more about angles and circles and how angles fit into circles, and we'll even throw some fractions in there. But we're going to be working on the guided practice and the independent practice. So you're going to be working on pages 345 and 346 in your books. So the first question, number 15 says, Mr. Smith said last week Julia was against starting a recreation club at school, but now she has done a 180. Use math terms to explain what Mr. Smith probably means. So I want to go back up and look at some of our, I thought they had an example. Well, they kind of do on this example right here. Sorry for moving all around. But when we talk about this angle measure or a straight line, so when you think about drawing a straight line, so here, let me get my dry erase board. When you draw a straight line, sorry, there's kind of a glare. When you draw a straight line, this straight line measures 180 degrees. So from here, I'm drawing it backwards. From there to there is 180 degrees. So when you go from there to there, that's 180 degrees when you're moving it from that. So a straight line is 180 degrees. So now we're going to go to, I copied and pasted the activity so that way I could type it. So I'm going to pause for just 1 second while I have you guys get ready. Okay, sorry for pausing, but I wanted everybody to be on page 344, number 15. So I just thought it would be easier if I could talk and type as well as you guys are writing. So in a 180 degree angle, the two rays, the angle, because remember the two lines that form the ray, so it would be a straight line. The two rays extend in opposite directions. Mr. Smith is trying, or is saying, let's not say trying. Mr. Smith is saying Julia started with one opinion, but then she changed her mind to the opposite opinion. Okay, so that's what we should have for number 15, because again, the two rays in a 180 degree angle, flat like this, they go straight across, so they're going in opposite directions. So if she did a 180, she went from this direction to this direction. Okay? All right, now number 16. I'm not going to keep going back and forth since I have all of the questions copied. Explain. Mark says that an angle showing a turn through 1/4 of a circle that is 10 inches across is 2 times the measure of an angle showing a turn through 1/4 of a circle that is 5 inches across. Is Mark correct? Explain your answer. Now, this is a lot of information and it can sound really, really confusing. Okay? But if you think about a circle, and if you think about dividing that circle into 4 parts, or if you're showing 1/4 of that circle, 1/4 of that angle measurement, that it doesn't matter how long your how many inches across the circle is. It doesn't matter the size of the circle. If that circle is divided into 4 parts and you're looking at that angle measure, it does not matter the size of the circle. We're still talking about that angle measure. So when we're talking about the angle measure, I'm and not to get that glare for you guys. So you see the two different sizes of my circles, and it doesn't matter the size of the circles. We're talking about the angle measure. So it's still divided into 4 parts. So it's still 1/4 of the circle. Okay, so it would still be 90 degrees because 1/4 of 360 degrees is 90 degrees. So we're going to go ahead and write our answer together of what we just talked about. So Mark is not correct. The length of the rays in an angle don't affect the measure of the angle. All circles have 360 degrees, no matter the size. So 1/4 of any circle is 90 degrees. So I hope that makes sense. I'm going to pause the video so you have time to get this in your books. Okay, hopefully I gave you enough time to get it written down in your books. If I didn't give you enough time to get it written down in your books, then please do not hesitate to pause this video and finish writing. So number 17 of the guided practice, which is greater? An angle showing a turn through 1/6 of a circle or an angle showing a turn through 1/5 of a circle? Explain your answer. So again, I found something and I drew, so I'm sharing this with you. I'm gonna try to move my picture. So I'm sharing this with you. Please disregard my drawing. It's not perfect. I freehanded this, so I used this tool up here to draw the circle, but I wanted you guys to see. Now they're not perfect, they're not exactly equal, but you get the idea. So we're gonna go back to talking about fractions, which we talked about. We spent so much time on fractions. But when you look at this circle is divided into 6 parts. So we're talking about this angle measure right here. Okay, sorry, I didn't mean to make a circle. And then when we're talking about 1/5, we're talking about this angle right there. Okay, I don't know why it's making circles, but it is. So anyways, when you're thinking about fractions and you're thinking about the denominator, we have 1/5 here and 1/6 here. The parts, when you divide a circle into 5 equal parts, each part is going to be bigger. Remember, the smaller denominator is going to have bigger parts. So when we go back to our explanation, we can say if you divide the circle into 5 equal parts, each part will be bigger than a circle with an angle through 1/6 of the circle. So you explained your answer. Dividing it into 5 parts is going to be bigger. You can also take it a step further if you wanted. And when we worked yesterday, we said 1/5 times 360, and you could figure that out to be 72 degrees. And then 1/6 times 360 equals 60 degrees. So then you can see right there that 72 degrees is bigger. So whichever way makes more sense to you is the way that I want you to understand it. So I'm going to pause this video for a minute so you can have a chance to write this down, and then we'll move on to the last question. Okay, welcome back. I hope that gave you enough time to, write your answers down. So we're on to the independent practice, number 18, and it has 3 parts. It has a part A, a part B, and a part C. So they wanted you to use 2 4-inch strips of cardboard and 2 8-inch strips of cardboard with a brass fastener, and they wanted you to make, these are angle explorers as shown below. So they wanted you to use the 8-inch angle explorer to make an angle that turns 1/4 of a circle. Then they wanted you to use this 1/4 inch of an angle to make through 1/2 of a circle. You can use the corner and edges of a piece of paper to help make the angles. Describe the relationship between the two measures of the angles. I copied and pasted this picture so it has the lines in it, but we're going to actually answer it down here. So again, I made my dry erase board right here, and I showed 1/4. I showed the 1/4 right here, which is 90 degrees because it's divided into 4 parts. And then over here, I showed the 1/2 dividing the circle into half, which is 180 degrees. And if you remember from our problem before, when it had the different lengths of the circle, it doesn't matter the length of the rays don't matter. It's what the angle measure is. So we are going to say the angle made with a 4-inch explorer is twice the measure of the angle made with the 8-inch explorer. Now remember, it has nothing to do with the length of the ray. It has nothing to do with the 4-inch and the 8-inch. It has everything to do with the fact that 90 degrees 1/4 is, when you double 1/4, you get 1/2. Okay? Because 1/4 plus 1/4 gives you 2/4, which is the same as 1/2. Or if you're looking at the degrees, 90 degrees times 2, or 90 plus 90, gives you the 180. So that is part B. So it is twice the measure of the angle. We're talking about the measure of the angle, not the length of the rays. So I want to make sure you understand that. And then part C says, explain how you found your answer. So we found our answer because an angle that is half of the circle is the same size as if you combined two angles that are 1/4 of a circle. The length of the rays do not affect the measures of the angles. So I hope that this made sense. I hope that you understood it. I hope that this was brought, that I was able to give it to you in a format that made sense to you. If you have any questions or if you're having trouble with anything, please don't hesitate to reach out to Mrs. Davis and myself. We'd be more than happy to help you with anything. Good luck. I hope you have a great day. And don't forget, we have a quiz over angles tomorrow. So have a great day, guys. Bye. Miss you.